Happy Monday. Welcome to Geography 358, your weekly installment. Today is Lab 3. We are going to be working with map projections and measurements. So you want to come to Blackboard. The PDF, the lab instructions are here, as well as some data. You need to download the data and put it in your Geography 358 workspace in the Lab 3 folder. You will need to unzip your data. So again, on a Mac, you can just double click. On a PC, you right click and somewhere in here you should be able to extract your data. I already have it downloaded. I already had it unzipped too. All right, and as always, I am using the virtual lab. Sign in. Go to Linley 310. All right, so I have signed in to the virtual lab. Open ArcMap. So create a blank map. So you will probably need to add a folder connection to your Lab 3 workspace. All right, oops, rename it. And then, let's see. All right, so we want to add these 3 shape files to the map. So continental US, selected cities, and lat long. All right, so we want to change the name of our data frame to US cities. So this right here where it says layers and it has this, they look like post-it notes, this is a data frame. And so it contains all of the layers that we have here in our map. You can have multiple data frames in one map document, which we will do later. So that means you can also, the default name is layers, but you can change the name. So we want to change it to US cities, and there are a couple different ways to do that. Like you can see, you can just click in this box and change it. You can also double click here and change it right here in this general tab under name. All right. Oh, and we also want to make sure that the display units are set to decimal degrees. So the display units are here. those display units are the latitude and longitude coordinates of wherever the map cursor is on the map. So you can see that they are already set to decimal degrees, but if you do need to change it, that is under coordinate system, no, data frame. Oh, sorry, right here. General display decimal degrees. So you can also have it in miles or meters, whatever you want. But today we want decimal degrees. And so this question is just asking you what are the latitude and longitude in decimal degrees of these cities. It's asking you to just write that down using this method, right, where you're just hovering over one of the cities and then recording the decimal degrees as you see them down here. Because the point is then to show you how much more accurate it is when you use the identify tool. So you can, it's right here, this eye, click on one of your cities, and it has the exact location here. Much more specific. You can see that there are a lot more significant figures, so more decimal places here than there are down here. So you'll record those as well. All right, so now we are going to change the projection of our data frame. Oops. So that you can see the difference. So here, properties, coordinate system, we're going to change it here. So come to projected coordinate systems, continental, North America, and then US contiguous Lambert conformal conic. Continuous Lambert conformal conic. All right. And then, so just highlight that and then hit OK. And you can really see how the map changes, right? Because now we've, instead of just being that squared grid that we saw with the other projection, or the other coordinate system, this is actually projected. So this is, you know, to some degree replicating the way these features lie on the curved surface of the Earth. And so this has you do some measurements. So again, this is this little ruler is your measurement tool. And that is what you will use. Let's see, where are my cities? Sometimes if you do something while your map is loading, while it's drawing these features, it will stop drawing. And so there will be something down here that usually says canceled. And if it does that, if you can't see all of your features, you can always click this refresh button and it will draw everything again. And so for those of us in the virtual lab, this is a bit slower than it is if you have it installed on your own computer. Okay, so there are cities. So let's see, that is not snapping. So let's figure out why. So let's change this. You can see that it's in meters. So I don't know about you guys, but you know, 2 million meters doesn't really mean a lot to me. So remember, you can change your units here. Use whatever you feel most comfortable with, depending on where you're from. Kilometers might be better, miles might be better. So you can double click to end your measurement. So from Kansas City to Los Angeles, it's about 1,300 miles, so 1322. So now we are going to change the coordinate system again to see how that measurement shifts. So again, double click here on your data frame. So now we are going to change it to, let's see, projected coordinate systems, UTM. So Universal Transverse Mercator, NAD 83, and then zone 15N, which I believe is our zone in this area in Lawrence. Okay. So the map changes again. It doesn't look so different this time because this is another projected coordinate system. So we'll do that same measurement. And so you can see here it went to 1352. So a difference of 30 miles is not an inconsiderable amount. You can think if you were an airline pilot or something like that planning a route, 30 miles is a big deal. So that's just to illustrate how important projections are. You know, different projections are good for different things. And so here, question 5, I want you to talk about that a little bit. Why are these measurements different in the different projections? And why is this important? So sometimes when you get data, it doesn't have a projection defined. So let's add in this Kansas City's. So it gives you this error. It's an unknown spatial reference. So we need to define it. And so in the case of this lab, we know what it is because it's in the lab. But that's not always the case when you're working with data that you get off the internet somewhere. Usually it can be found in the metadata or somewhere on the site. If for some reason you are unable to find the coordinate system for data, you can't really just make one up. So you may need to email somebody, ask the system administrator. But if you have data that was created in a certain projection, it needs to be attached to that projection. You can't just give it a different projection and have everything light up. So we're just going to say OK here. And then we are going to use a tool in Arc Toolbox. So that is this menu here with the red toolbox. You can just click on that. And these are just a lot of the different tools that you can use. We will be certainly using a lot of them in the course of the semester. So this is a menu also that you can pin here if you want. So you can just grab it, click and move, and you can see these different places where you can dock it up here. So I really like to have these menus docked here on the side. And then you can just click that push pin and it will hide that menu when you're not using it. So we are looking for the Define Projection tool. So that is under Data Management, and then Projections, and then Define Projection. So what this tool is doing is it's allowing you to specify the projected coordinate system for that shapefile Kansas cities that did not have one. So because that shapefile is a layer in our map, you can select it here. You can also use this folder to find it here. And then we are going to define this as NAD83 again. So that's North American datum that they measured in 1983. So just click this button here, and let's see, we've got geographic coordinate systems, North America. So this is an unprojected coordinate system. USA and territories, and then NAD 1983. All right, and so you can see the different parameters of the coordinate system here. And so I think maybe there's a question asking you to specify some of these. So we'll say OK, and then OK again. And see how all of these have locks on them right now? That means that ArcMap is doing something, and so you just have to sit and wait. All right, so ArcMap is done processing, and you can see these are no longer locked. It is redrawing the data. It's also going to pop up this little menu very slowly right here. And so this is just saying that the tool ran successfully. So this indicates that it was a tool, green check mark, it was successful. If you are ever unsure, you come to geoprocessing, and then results. This is a history of all the tools that you have run in your current session. And so if you get an error, if something isn't working, this is where you would come to figure out what that error was. But so you can see that our Kansas cities are in our map now. So let's right click on this and zoom to layer. This is a really easy way to investigate your map. It's going to just zoom you in to the extent of one of your data layers. Okay, and so this next step is going to be similar to what we just did, but we are going to create a new shapefile with these Kansas cities in a different projection. So what this tool is going to do is actually reproject the data. And so these are very complicated mathematical transactions that translate the spatial coordinates from one coordinate system to another. So we will come back into Arc Toolbox, and in this projections and transformations again, we are going to come to project. So you can see that this is a different tool. And so our input is Kansas cities again. And so it specifies the input coordinate system there. So now we need to tell ArcMap where we want it to save this shapefile. So click here, and we will be able to browse to our Lab 3 workspace. And here we will type in the name, which is going to be Kansas Cities state plane because that is the coordinate system that we're going to project this into, and we want to save it just like that. All right, and so here we are going to specify the output coordinate system. So just click this box here. And so we will navigate to projected coordinate systems, state plane, and then NAD 1983 meters. And then state plane Kansas with the FIPS code 1501. So this one here. And just as an aside, if these menus get pretty deep, if there's a coordinate system that you use a lot, you can just click this star here, add to favorites, and then you can see that that is just in this favorites folder right here. But so we want this to be selected. We will say OK, and then click OK here. And that tool is going to run. You can see it here. For some reason, not all tools will display this, but this just tells you that ArcMap is working, it's actually doing something, and it is projecting those Kansas cities into a different coordinate system. All right, so it pops up here again. Our tool was successful. And it did not add automatically to our map, so we want to add it here. You can see that this additional shapefile has appeared in our Lab 3 folder. So you can just drag that onto the map and another nice thing about this geoprocessing menu here is that if you come back to results and then double click on a tool, it will open that tool again with the exact parameters that you specified before. So I think what's happening now is that it didn't like that I saved that shape file on my own Mac computer. So I'm going to save it on this Linley 310 computer. So I need to connect to another folder. And so you can save to this D drive here. So we'll name it again, save, OK, and hopefully this will work. All right, so hopefully this worked. Let's give it a try. Yeah, there we go. So anybody who is working on the virtual lab, you are going to need to not save these output files on your Mac. You need to either save them somewhere on this Linley computer. Like I said, I use the D drive. You could also save it on the desktop, but after you log out, that will be gone. You can also connect to your OneDrive folder. You get something like a free terabyte of storage through the university. If you're interested in that, I have a video on how to connect your OneDrive and use it with the virtual lab. I will make sure and put that on the Blackboard site under resources. All right, so now we want to change the symbology so we can see how they're different. And they are not. And that is because ArcMap does something called on-the-fly projection, which means that when you add in layers that are in different projections, it automatically and kind of behind the scenes reprojects all of the data so that it is in the same projection as whatever the first data layer that you put in was. It's not actually changing the data itself like the way we projected this using a tool, but it is displaying them in the same projections. And so that's important to remember because some of these geoprocessing tools that we're going to use can produce very different outcomes depending on the projection of your data. So you always need to know actually what your data, what projection the data is in, and not just to assume that it's the same as everything else because it's displayed in the same manner. All right, so we are going to show these in different projections and make a map doing that. So we are going to add a new data layer so that we can display the two different projections in the same map. So if you come here to Insert Data Frame, you can see we have our new data frame here. And so we are going to move this into our new data frame. And then we are going to copy this. So you can right click, copy, paste layers, because we want this in both. Oh, and actually I guess just dragging it down here copied it also. So we will turn this off there, keep it on here. All right, and so let's make sure that this is in state plane. So double click on here, and yeah, you can see under coordinate system that it is in this state plane, which is what we want. So let's rename this state plane. Let's check and make sure that this is, yep, in NAD 83. So let's change this name to that, NAD 1983. So the what we're seeing here on the map is the active data frame. You can tell it is this one because this is in bold. So if we wanted to see this instead, you can just right click and come down here to activate. And so you can see that we're in this different map now. So what I want you to do is create a map with both of these data frames so that kind of a comparison of these two different coordinate systems. So if you come here into your layout view, you can resize these so that they both display. So you can see you've got your two different data frames. So one nice thing that you can do is if you hold down your control or command and so that you have both of them highlighted, and then you can right click and then there are certain ways that you can align them. Here what we're going to do is we're going to make them the same size. And now let's align them to the center. And that makes it easy to make a good looking map. So we can remove this because we don't need it. And let's zoom to layer on both of these. We can remove this too. All right, and so you can see, oh my gosh. These look pretty different, right? You can see here how curved this one is, and this one's pretty straight. And that is just the difference between these, oh my gosh, between the two coordinate systems. So one thing that I want you to do also is to display Lawrence differently than the other cities. And so the way that you're going to do that is we learned it in the last lab. You come in here and open your attribute table. There are different ways that you can select the city of Lawrence. Since we're just selecting one city and there aren't that many in this data layer, if you just double click on the field name here, it will put these in alphabetical order. So you can just come down here to Lawrence and highlight it. And then we can close this because we don't need it. And then if you right click here and then under selection, create layer from selected features. And it will add this layer here, which is only the city of Lawrence. So clear your selection and then make this something different, like a red star, whatever you want. Maybe make that bigger too. And you want to make sure this is on top here. Otherwise, it wouldn't show up because it would be hidden by this. So remember, you can just click on the symbol itself to change it. And then we can drag that down here. And then you're going to want to add a legend and a north arrow and a scale bar as well. And so because these are in different projections, those scale bars are going to be different. So you need to highlight and then insert your scale bar and do the same thing here. You can see that they're different. They even have different units, and that is because these different projections use different units to specify the projection. So just follow these instructions, make a nice map, and then remember you need to export it, you'll save, and then export it as an image file. And then you are going to submit that image file to Blackboard. So hopefully that was clear. If you have any questions, just let me know.